Hey there, welcome back to another video, and in this video we are going to take a look at locally weighted regression. So without wasting any more time, let's get into the video. So as the regression that we have done until now is a simple linear regression, which means that if you want to use your regression on this data, then it is not going to work because this is not a linear data, and linear data is the data that you can linearly separable, in means that you can separate that data with a single line. So this would be a, if you will just apply your linear regression, then what you will see that you will get a line like this, which is not correct because there are some data points here and there are some data points here. So this is not correct. So what I am going to use, I am going to use locally weighted regression, in which what it is going to do, it is going to draw a line like this. And locally weighted regression I am gonna use with closed form solution, because you have to do every computation on the runtime. You cannot store every data, because for every test point that you want to see, you have to uh, get the optimal theta for that specific point. So that's why I'm gonna use my what do we say, closed form solution, and it is going to be fast with closed form solution. So in the future we are going to find a better algorithm, or we are going to learn a better algorithm that can implement this part, and we do not have to find the optimal values of theta for every test point. So that is going to be another video, but in this video we are going to talk about locally weighted regression. Basically this is the formula for locally weighted regression. So as you can see here, this is the same formula as closed form solution, and we just have included a matrix which is a diagonal matrix between these terms. And now if you will apply this, then what it is going to do, it is going to generate a non-linear line, and I'm going to explain like how it is going to do in a minute. Okay, so it is going to use this formula to find let me just start from scratch. Okay, let's suppose you have this data, let's suppose, and what do you want to do is, let's say you want to find a point, uh, let's say you want to find output for this point. Okay, so what you can do is, you are gonna draw a line based on this point like this. And now the main idea behind here is that the points that are closer to the our original point, our original data point, or our original query point, which is this, is going to impact on this line. But the points like these, which are not close to our original or test point, these are not going to impact this line. And how it is not going to impact this line? As you can see here, we have our loss function, it is called as weighted loss, and we have our normal loss function like here, and we are going to multiply it with this value. Now what this value is going to be, let's suppose you are finding the error, because if you are if you know gradient descent, so with gradient descent you have to find the derivative of this error, and on the basis of this error you have to update your theta value. Okay, so let's suppose if you do not consider these values, then what it is going to do, it is going to make this line. Okay, and how it is not going to consider this value, if the error on these point, because normally if you will just create a line like this, and you will check the error on this normally with this loss, then it is going to show a very big error because of this gap. So what are we going to do is that we are going to multiply that loss with some value. This is that value, and this value is going to be closer to 0 if these points are uh, away from our test points. So as far as these points are going to be, it is going to be closer to 0, and if they are going to closer to our test point, then this wi is going to be 1. So this is the basic idea basically behind how you can find a line like this, and we will see when you will explain, you will understand this when we will do this in our code. And now if you'll see how you can find the error, or how you can find the distance between them, then you can use this formula, and here we have to use this. So what it is going to do, okay, so it is, this is tau, and we are gonna use this function. So if e is going to be 0, e to the power is e to the, if this is going to be e to the power 0, then output will be 1. So loss hour will be normal. So let's take an example. Let's suppose you have this input, and 1 2 3 4 5 6 7. So let's say, let's take this, and let's suppose you, this is the 7 data point, original data point, and you are giving it your test point as 7. Okay, so for 7 part, for this point, what it is going to do, it is going to minus 7, minus 7. This 7 is our test point, and this xi is the point for from our data. Okay, so this is going to be 7 minus 7, and it is going to be e to the power 0, which is going to be 1. So it is not going to impact our loss at all. Okay, now let's suppose, okay, so now let's suppose what you have here is, uh, let's take, you have 45. There is a point on 45 value, like here, let's say this is 45. So 45 minus, and you are giving your point again 7. So 45 minus 7, so this is going to be 38, and you have to square this, so 38 square, and then you are going to divide this value by, with this 2 tau square, and tau is going to be a value that is going to be, that is going to make your program sensitive, like how much value is going to decrease with the distance. Okay, so let's take tau as 5 for now. Okay, and let's do some calculations. So what it is going to do, let's take 38 square. So 38 square is 1444, and our tau is 5, so 5 square is 25, and 25 into 2 is 50, so it is going to be divided by 50. Okay, it is going to be 28.88, and we also have negative, so we also have this negative, so this value is going to be minus 28 point, so e to the power minus 28.88. So let's see what it is going to be, and as you can see here, it is a very small value. So when you will multiply this very small value with your loss, so that loss is also going to be around 0. So this is not going to impact your main data, and we will see, or we will discuss more about this in the next video, in which I am going to implement the code for this. So thanks for watching, and I'll see you next time.